Hello everyone, this is Steve, KG4LJB, with a short video that illustrates the utility of the SteppIRTest Test and Evaluation Board when trying to determine if your controller is producing the drive pulses needed to change the tap of the coil used with SteppIR's vertical antennas. Unlike the EHU driver that produces a long-lasting stream of pulses when changing bands, the pulses that drive the motor that turns the coil tap switch are quite short-lived and occur only during very specific frequency transitions. Trying to detect their presence with a digital multimeter is a difficult and frustrating exercise. Conversely, detecting their presence with a SteppIRTest board is a walk in the park. First, please ignore the check fault indication. The antenna control cable is not connected, so this is expected. In this example, I'm using an SDA-2000 configured to control a bigger vertical with the 80-meter coil. Later in this video, I'll repeat the process with an SDA-100. I'll leave a list of transition frequencies in the video description. One of the transition frequencies occurs between 3590 and 3600 kHz. In a moment, I'll reposition the camera to view the SteppIRTest board. Then, as illustrated here, I'll turn knob K2 back and forth, changing the frequency between 3590 and 3600 kHz. Each time, the LEDs associated with the coil driver will briefly flash, and I do mean briefly, indicating the presence of the drive pulse. Naturally, if the driver circuit inside of the controller has failed, then there will not be a flash. This is the SteppIRTest One Test and Evaluation Circuit Board. It is capable of assessing SteppIR's 1, 2, and 3 element antennas, ranging from a dipole or a vertical with or without the coil, up to the DB18E. Also available is the SteppIRTest Deluxe. It can facilitate testing of all of SteppIR's current antenna products. The SteppIRTest One has 3 groups of 4 LEDs. The vertical EHU drive pulses are detected by the left group of LEDs. The coil switch drive pulses are detected by the middle group of LEDs. In this example, ignore the group of LEDs on the right. They are only used with 3-element antennas. At the moment, the controller has completed its tuning cycle. The fairly dim LEDs illustrate the presence of the holding voltage that locks the EHU in place and prevents the return spring from compromising the calibration. In a moment, I'll turn the knob K2 back and forth, changing the frequency back and forth between 3590 and 3600 kHz. The left group of LEDs will show the drive pulses to the EHU SteppIR motor. If your cable is good and all is well mechanically, the tape should extend and retract. Pay attention to the center group of LEDs. They will briefly flash as the controller transitions back and forth between 3590 and 3600. This indicates the presence of pulses that will move the tap switch. Here we go. As you can see, the pulse is very short-lived. I'm going back and forth, and the flash is ever so brief. Detecting the presence of these pulses would be extremely difficult, likely impossible with just a meter, and cumbersome at best with an oscilloscope. Naturally, if the driver module or IC has failed, the flash would not appear, indicating the need for driver replacement. Usually, a driver failure also results in the loss of the holding voltage. So if, say, these center 2 LEDs were not currently lit, yet the left side were, that would indicate driver failure. And you'll notice at the moment you plug the board in, even if the controller has not been turned on, because the the holding voltage is maintained even when the unit is off. If that wasn't there, then the spring would pull the EHU tape in and compromise your calibration. I've traded out the SDA-2000 for the SDA-100. I've also traded out the SteppIRTest One for the SteppIRTest Deluxe, which you'll see in a moment. The control cable is not connected to the controller, so consequently you're going to see that driver problem. Driver's fine, it's just it doesn't detect the presence of the EHUs, so it's going to present that error message. Please ignore that. I pre-tuned the frequency to 3590, and I will use the fine up and down buttons to transition to 3600 and then back again. In a moment I'll reposition the camera so that you can see the SteppIRTest Deluxe board, and essentially you're going to see the same thing. The SteppIRTest Deluxe is essentially the same board with 2 extra channels, if you will, for the additional EHUs used in the larger antennas. This is the SteppIRTest Deluxe test and evaluation board. It can process and test any of SteppIR's current antenna products. You'll note that this channel currently has no illuminated LEDs. That's because I had a driver failure and decided to borrow its driver module in order to get a needed, I think it was the reflector that needed a fresh driver. So transplanted that and got my situation going again for the antenna I was using at the time. The coil, once again, is being monitored by this channel, and the EHU for the bigger with 80 will be illustrated there. And now I'm going to change from 3590 to 3600, and again pay attention to this group of LEDs as I transition back and forth. Here we go. As you can see, the SDA-100 behaves in the same way as the SDA-2000. I haven't tested a fluid motion controller that was set up for a bigger with 80, but I assume that the process with it would be the same. Thank you for watching my video. If you have any questions, please feel free to leave a comment. I'll respond to that, or if you like, you can get my contact information from the SteppIRTest.com website. 73. One final thought. I thought it might be interesting to demonstrate a coil actually attached to the SteppIRTest board on the workbench. As you can see, we have an 80-meter coil, and that has been wired directly to the SteppIRTest board. The green terminal strip offers a lot of utility. Makes it easy to measure the resistances of the various EHUs, and because of the way the artwork surrounding the connector is laid out, you have excellent situational awareness as to what EHU you're dealing with, and if there's a problem, you know where to focus your energies. You'll notice that the holding voltage for the coil, the LEDs do not currently present enough light to be seen. It's there, but it's very dim as a result of being loaded down by the motor that turns the switch. However, when I change frequencies from 3590 to 3600, you'll see it light up brightly. You'll also see the coil turn. You'll note the brief flash showing the loaded signal that goes to the motor. And in a moment, it completes, and the holding voltage is not present. Holding voltage is rather low. Depending upon the model of controller, it's typically in the neighborhood of 3 to 5 volts. The old fluid motion units produced about 5 volts holding voltage. Anyway, I thought you might find that useful. The SteppIRTest board has a lot of utility. I'm going to be making more videos that depict the various ways you can use it for troubleshooting. Thanks for watching.